Hello. So today we will be going over the 1999 Venezuela flooding and debris flow. So to first kind of set the scene, I'm going to explain um, where this event occurred. So it happened along the narrow coastal zone north of Caracas, Venezuela, in the state of Vargas. This area is surrounded by very steep mountains, and it's highly populated. So because of these steep mountains, they are very vulnerable to episodic rainfall-induced landslides. Um, there they are the people of Venezuela are forced to build in these areas even though they know it's dangerous because the mountains are too steep and too rugged to develop. They can't live there. Um, it the area that they builds these towns in is called an alluvial fan. This is an area where sediment is deposited as um, a river decreases in velocity. So they know it's dangerous, but they have to live there. So the weather patterns that caused the 1999 flooding and debris flow. In December of 1999, there was an unusually wet period. December 2nd and 3rd, there was a total of 200 millimeters of rainfall. And then there was a major storm that totaled 911 millimeters of rainfall from December 14th through 16th. So these alluvial falls where these people live in urban and rural areas are sites of episodic rainfall-induced natural hazards. So they are normal, but this particular event was massive. Magnitude in space and time. So this occurred in the coastal zone of the state of Vargas and neighboring states in northern Venezuela. The flooding and debris flow affects the alluvial fans region of the coastal zone in Vargas, and at least one or two high-magnitude flash flood or landslide events have occurred per century in this region since the 17th century. And in this particular event, the volume of material transported by the landslide throughout this region ranks as one of the most severe historical erosional events worldwide. So in this picture to the right, you can see a woman standing next to this huge boulder. This boulder was transported during the debris flow, and I mean, it was previously not there, and this just shows the massive amount of material that was moved so rapidly, and it caused a lot of destruction. So societal and economic impacts. It's estimated that this flooding and debris flow in Venezuela killed about 19,000 people. It caused extensive property damage, as you can see in this picture. It changed hill slope, stream channel, and alluvial fan morphology. Hundreds of houses, bridges, and other structures were damaged or destroyed, and it totaled about $1.9 billion of damage in a country that is already on the poorer side. So, mitigation or adaptation strategies. Two strategies to protect property from this type of natural hazard are large structural flood control measures such as dam checks, which is an example is pictured on the slide, or just avoidance of the affected area. There can also be land use regulation to reduce hazards by limiting the type or amount of development in high-risk areas. Also, they could just use early warning systems to reduce loss of life. Examples of these would be sirens or radio bulletins to alert residents. None of these strategies were used in 1999 in Venezuela. That is why this event was so catastrophic. So, just to finish out, I have this short video clip. It just really, I just want to look at some of these pictures here, and they really just show how much damage was done. All this mud was transported in the debris flow and landslides, and it just destroyed houses, and yeah, I see it destroyed all these houses. I just think this video helps you to gain more understanding in um, how severe it really was. Okay. Okay, that's enough. Um, Sorry. Okay. And that's it. These are our sites, and then I hope you enjoyed that. Thank you.